Hey guys, welcome to a short episode of Shop Talk. If you noticed, a while back I rearranged my benches in here, and I'm constantly finding that I'm having to keep moving stuff around. And now that I got the microscope and I got those other two multimeters I just picked up, and this big 8520, once I get it fixed, I got to make room for it, since the corner over there is the deepest place. It's probably going to go up there over top of the 8640. So got to make some more room here and get some things situated. But I just want to throw in a couple updates and look at a few things. My old Sencore CS61 has been giving me a little trouble here lately. I've got to get this thing tore down. I'm going to tell you, out of all my scopes I have, I like this one the best. I just like the way the scope works, how it, you can read frequency and voltage and everything right up here on the LCD while you're looking at the CRT. But as you can see, it, when I bought this thing, they had dropped it. They had cracked the front corner of it and fixed that, but every now and then, you see when I move the channel 2 vertical position, you see it go up, but you see channel 1 go down. And same thing with channel 1. And then sometimes the lines, the traces just go jumping all over the place, and so there's a loose connection in there somewhere. And sometimes you can tap it and you can see it jump up and down. Gotta get that fixed. This scope, just when it works too good, and it kills me when it's not working right, 'cause I just love the way that scope works. One other thing about this Amscope, if you look right down the top of the eyepiece here and here, there's two little screws, set screws, that holds the eyepiece in place. This unit did not come with those screws, and I went through everything in the shop trying to find some, and couldn't find nothing that fit it. And I finally robbed some out of an old iPhone I had laying here. They were the perfect size. They ain't quite as long as they should be. I mean, I can still move the eyepiece, but at least now it's not coming out. I was worried about if I pull the cover off, and it get caught on it and pull the eyepiece off and hit the floor. So anyway, yeah. So if you order one of these, check your screws. I can't really say if they were there and I pulled it out and they fell out, but they're tiny little things. And like I said, I got my microscope, and I finally moved it over here in the corner, and this way I can push it right back, turn the head around, put the cover on it, and it's back there out of the way, no problems. So I think that's not a too bad a place, and plus it reaches out. I can sit right here in this corner and use it with no problem without getting fatigued or anything. Did get me a light ring. No, I didn't buy it. This is a homemade light ring, as you can say. Real simple. Gets the job done. I've got the power supply and a little project box over here. And cut it off and on. And what this actually was, it was a magnifying lamp, and it came with this cheap Chinese Xtronic sorting station, and I never used it, so I tore it apart, removed the magnifying lens out of it, made a bracket, bolted it right up underneath the Amscope, and two existing holes, and just run a wire off of it. Works real good. Plenty of light. Now y'all remember when I pulled the cover off the 8520A, we saw this burnt mark up here. Well, there was something else there. Paul from Mr. Carson's lab, he once said something on one of the videos that is sort of kind of stuck with me since he said it. And he was talking about a piece of equipment I was restoring, and he was, you know, I was kind of complaining about the way some things were done, this and that in it. But something that Paul said was, that was telling the story. You know, the piece of equipment is giving us its life story. And when you look through this, you'll find that a lot in equipment. You know, Paul opened my eyes to that. I never even gave it a second thought, but yeah, he's right. And this burnt mark is telling us a story. And I never noticed this until one of our viewers, Sporadic C, he made this comment. And if you look right here, there, do y'all know what this is? That's a fingerprint. So whoever was working on this stuck their finger in this burnt mark and left that print there. So if we can ID this fingerprint, we knew who worked on this thing. Anyway, I just thought I'd share that with you. And say thanks to Sporadic Z for pointing that out to me. Very interesting. So a little bit last night and some this afternoon, I got a chance to get back on the 8520A and doing some tests over here on the DC buffer stage, when all of a sudden, you know, just sitting here, a big puff of smoke came out and looked like somebody was welding inside of it. Well, this resistor went up in smoke, and when I checked, what I found was this second tantalum decided to commit suicide. So I've already gone in here and made a parts list, and there's 62 tantalum capacitors in this unit, and I think that was a total of 6 electrolytics. So these tantalums are a nightmare. Now, you know, why do they use tantalums in a circuit like this? Well, you know, tantalums are more precision. You know, they're closer in tolerance. But unlike electrolytic, when these die, they die in, you know, short. They don't blow open. You know, and stay intact. If they blow and blow open, you're going to find pieces of this capacitor everywhere in here. I mean, they're like little bombs going off, and I've even seen blown holes in circuit boards before. So yeah, but you know, kind of interesting. Just sitting here and all of a sudden it started smoking, and when I started checking, the capacitor had a complete short across it. Oh well. One other thing, you know, I told you before, if you move J19, we can get no errors on the front of the unit. Everything, you know, push button works. Never hear the relays over here kick in. You know, nothing ever changes on the input. So, you know, we know we got an input problem. We got voltage on the input. But I found it interesting while I was in here doing some testing and following the schematic alone. Let me stop just a second to show you. Okay, but what I want to tell you was that the engineers that designed this thing, they knew what was going on. You know, they got everything labeled here. They've got test points in here that are big enough to do something with. You know, they're big enough to get to. So, you know, you got these big old lug test points, you know, just all over the board in here. And that really helps when you're testing. But like this jumper, like J19, and I started doing some tests, and you know, it's just like an IC chip. You just pull it out. It's just a socket, and you got your, you know, your pins right here on the bottom. But what you can do, you can start down here and you can plug it in, turn it on, do some voltage testing. No problems, you know. You're not going to short nothing out. You can pick it up and then you can plug 2 of them in, and you can do some testing, and you can, you know, this and that real good, and you can keep on until you get all the way down. Well, when you jump everything but pin 1 and pin 14, it's all good. I can measure like 10 volts on this pin 14, but as soon as you jump 14 and 1, that 10 volts goes down to like 0.5 volts. And the transistor over here, Q229, right here, has 10 volts on this leg here, the emitter, and as soon as you plug it in, that goes all the way down. So, you know, I tested the transistor was fine. So what does that tell you? That tells us that there's probably another component that has failed shorted, because I have got a direct ground from pin 1 to chassis ground of this chip right here. And I got a little cheap analog meter here. Turn this light down, get some glare off of it. And you see, if we check pin 1 here, but when we go to the other side, boom, dead short to ground. Now, when I looked at the schematic, this pin is connected to the A to D inputs. And where's our problem at? It's in our input. That's where we have high voltage on our inputs. So, yeah. I think that tells us that we're going in the right direction. So whatever's killing the inputs, you know, there's a signal goes through these 2 pins here that's got to be looked at. So, yeah, but you know, it's one of these things. You know, do you keep tinkering with it and try to go ahead and fix everything, and as you're working on it, you're gonna have, you know, the tantalum capacitors blowing left and right like walking through a minefield. It's probably best I'm gonna go ahead and make some orders, get these tantalum capacitors out of here and replace them with some new ones. Like I say, there's like over 60 of them. You know, you got some, most of these big ones, they are 6.8 at 35 volts. But then you got some small ones in here. And, you know, I got mixed feelings about not changing them. It's just, I don't know, even the one that was over here by this regulator, 8-volt regulator, you know, that was a 10 microfarad at 20 volts. And we saw that it was, you know, went shorted. So a lot of work changing them out, you know, 60 capacitors. We don't change them now. We'll probably have to change them later. And, you know, I'm planning on keeping this piece of equipment and using it for myself. If this was in repair for a customer, then yes, every one of them will get get change, no questions asked. But you know, that's when the customer's flipping the bill. When you're pulling the money out of your pocket yourself to do it, that's when you wonder, you know, just how far down this rabbit hole do we want to keep going. I mean, I want the thing fixed, and I want it fixed right, so I'm just going to probably have to go ahead and bite the bullet, replace all of them. Anyway, just a few updates. Decided to come out here in the shop tonight and play around a little bit. Decided I'd grab the camera and just do a little talk. Yeah, but anyway, I've heard people so many times saying, "Oh, they don't place tantalums, you know, don't mess with them." You know, I can't agree with that. Tantalum capacitors go bad, and they go bad hard. So they just got to be replaced. You know, this might make a little setback in getting the thing going, because you know it's going to cost a little bit. Some of them tantalum capacitors are a couple of bucks in here, so depends on where you get them from. I'm seeing about, you know, 20-25 cents different. Now, I'm not going to go out and order 1,000 6.8s. I probably ain't replaced 2 dozen tantalum capacitors in the last 12 months, so there's no way I'm going to go out and order that many just to get the price down, you know, for a bunch of jelly bean parts. I can't see it, you know, doing that. One thing I did like about the 8520A is when I went online and I downloaded the service manual and the operating manual. Well, I went ahead and printed out the large pages for the you know, the schematic, and I like the way they laid it out, because they'll show a board view, and in white is what they're referring to, and when you turn the page, that's the part of the schematic you're going to be looking at. You know, same thing when you go to this front panel board, you know, it's all in white, so all this part's going to be on one schematic. And what do you notice about this schematic? I don't know, you know, how many times it's been copied, but the detail of the schematic is just outstanding. Even though, you know, it was downloaded off the internet, it's just great to work through. You can see every number, you know, every symbol. It's all there. It's just real great to work with. And when a manufacturer builds something and they take the time to put this type of quality in their schematics, and you know how people get the PDFs, put them online, and they get copied over and over and over. These are just, you know, outstanding work. I mean, the detail is just amazing. I know a lot of times with all the ham radios I work on, we download stuff, you know, even Kenwood. You think Kenwood would have some good stuff online, but you know, a lot of it you can't read any of the numbers. You can't read values of components in this. It's really quite terrible. But yeah, they get a good job on the schematic. But I'd like to hear your comments. As always, leave them down below. And we'll conclude this little, I guess you can say, shop talk rant. And we'll catch you next time. See you now.